In just 5 seconds, a spoon can scoop up over 3 million times its own weight. From the dinner table to the lab, spoons have a rich history of helping us with everyday tasks and revealing mathematical patterns. A spoon is not just a simple utensil, but an engineering marvel that has undergone centuries of refinement. The design of a spoon is a delicate balance of form and function, with its shape and size tailored to perform specific tasks. For example, a teaspoon is designed to hold approximately 5 milliliters of liquid, while a tablespoon can hold around 15 milliliters. But did you know that the shape of a spoon also affects the way it interacts with different materials? Imagine pouring a cup of coffee with a spoon that is perfectly shaped to scoop up the crema at the top. In this case, the spoon's curvature would allow it to collect the crema with minimal spillage, creating a smooth, even flow. However, this is not the only mathematical pattern at play with spoons. When you dip a spoon into a container of sugar, it can scoop up an amount that is surprisingly consistent. This is due to the concept of surface tension, where the sugar molecules stick together to create a skin on the surface of the sugar. As the spoon breaks this skin, it creates a small depression that allows it to scoop up a consistent amount of sugar.
But what about the physical forces at play when you stir a cup of coffee with a spoon?
The spoon's shape and motion create a complex interplay of forces that can either mix or separate the coffee's components. For instance, if you stir the coffee in a circular motion, the spoon's speed and direction will determine the intensity of the mixing process. However, if you stir the coffee too quickly or in the wrong direction, you can end up creating hot spots where the coffee is either over or undermixed. And then there's the phenomenon of spoon resonance, where the spoon's vibrations can cause the coffee to splash or foam excessively. This is due to the principle of resonance, where the spoon's natural frequency matches the frequency of the coffee's movement. As the spoon vibrates, it creates a standing wave that causes the coffee to move in a specific pattern. But that's not the strangest part. Spoon resonance can also be influenced by the shape and size of the spoon itself. Imagine using a spoon that is specifically designed to minimize resonance, allowing for a smoother and more controlled stirring motion. In this case, the spoon's shape and size would be optimized to create a sweet spot where the resonance is minimized. And then something unexpected happened. Researchers discovered that the shape of a spoon can even affect the way it interacts with different types of food. For instance, a spoon with a sharp edge can be used to scoop up delicate foods like eggs or fish, while a spoon with a rounded edge is better suited for scooping up sticky foods like honey or syrup. But why does the shape of a spoon matter so much in these situations? The answer lies in the concept of friction, where the spoon's surface interacts with the food to create a specific level of resistance. When the spoon's surface is rough or sharp, it creates more friction, allowing it to scoop up foods more effectively. However, when the spoon's surface is smooth or rounded, it creates less friction, making it more difficult to scoop up foods. As a result, the shape of a spoon is critical in determining its performance in different situations. But what about the real-world consequences of these mathematical patterns? For instance, in the food industry, understanding the shape and size of spoons can help manufacturers design more efficient utensils for specific tasks. This can lead to improved productivity, reduced waste, and increased customer satisfaction. In addition, the study of mathematical patterns in spoons can also inform the design of other everyday objects, like kitchen utensils and equipment. As we continue to explore the world of mathematics, we may uncover even more surprising patterns and applications in everyday life. So the next time you reach for a spoon, remember the rich history and mathematical complexity behind this humble utensil. And if you found this fascinating, subscribe for more incredible stories like this. Want to explore more amazing discoveries? Join our community of curious learners and subscribe now. Thanks for watching, and we'll see you in the next video. Subscribe to explore more amazing discoveries.